Let's now take another example of an ion that exhibits resonance. This time we take the nitrite ion, NO2 minus. So this is NO2 minus. We begin with calculating the number of valence electrons in the nitrite ion, and that would be 5 from nitrogen, because nitrogen is located in group 5a, so therefore it has 5 valence electrons, plus 2 times 6 valence electrons from each of these oxygens, because oxygen is located in group 6a. And then we need to add the charge, because this ion is negatively charged. So the total number of valence electrons is actually 18. So 18 valence electrons available in this nitrite ion. If we divide 18 by 2, we get 9 electron pairs. So 9 electron pairs in this case. And then we begin with drawing the central nitrogen atom like that. That's oxygen, that oxygen. And then we draw a single bond between nitrogen and each of these surrounding atoms. And then we try to satisfy the octet for each of these oxygen atoms. So this oxygen has now satisfied the octet by being surrounded by 8 electrons. If you add 8 with 8, so you get 16, but we had 18 valence electrons before, so we have 2 to go, and these 2 additional electrons can only be drawn on the central nitrogen atom. And there we go, we draw them here. So but now, if you look at that nitrogen, yes, oxygen has satisfied the octet. Yes, there are 18 valence electrons. Yes, there are 18 electrons that are used up or have been used up so far. Nitrogen, the central atom, has not satisfied the octet. So this is not a possible Lewis structure. So what we need to do is we need to take one of these lone pairs and use it in order to make a double bond, to draw a double bond between nitrogen and that oxygen. If you look at this now, oxygen has satisfied the octet. It is surrounded by 8. Nitrogen has now satisfied the octet because it's surrounded by 8 electrons as well. That oxygen is also surrounded by 8 electrons. If you add the number of valence electrons used up in this Lewis structure, you will see it's 8 plus 8, that is 16, plus 2, that is 18. So that's in accordance with the number of valence electrons that we have obtained before. If you check the number of electron pairs, you will find it's actually 4 here, 4 there, that's 8, plus 1 lone pair on nitrogen, that is 9. So this is a possible Lewis structure, therefore, for the nitrite ion. What we need to do next is we need to put this or draw this in between square brackets. So something like that would be an acceptable Lewis structure for the nitrite ion. But again, just like what we have seen in the case of the nitrate, now why can't we draw a double bond between that nitrogen and this oxygen? Does it have to be between that nitrogen and that oxygen? And the answer, of course, is no. It is possible, yes, to have or to draw a Lewis structure where that double bond is actually between that nitrogen and this oxygen atom. So let's do that. So this is again resonance, just like the nitrite ion. The nitrite ion exhibits resonance. It is possible for it to have more than one Lewis structure. So let's do that. Okay, now we draw another Lewis structure, but this time the double bond will be between the central nitrogen atom and the other oxygen on the right side. So that's the double bond. That's the lone pair. We satisfy the octet for these oxygen atoms. We draw the whole Lewis structure between square brackets and the negative charge outside on the top right corner. If you look at this Lewis structure, you will see that the only difference between it and this one is the position of the double bond. 2 possible Lewis structures are available here. Therefore, the nitrite ion, just like the nitrate ion, exhibits resonance. This phenomenon of resonance where the actual structure is none of them individually, but actually an average of both of these possible Lewis structures. The actual structure is what's called a resonance hybrid. All bonds here are actually identical, not only in bond length but also in bond strength. Now, what we need to practice next is this idea or the concept of formal charges. Now, we need to calculate the formal charges of all atoms in these Lewis structures, okay? And the sum should be -1. If you look at that oxygen, the number of valence electrons for oxygen in the free atom is 6, so 6 minus. The number of non-bonding electrons is 4, and half of bonding, that's 2. So 2 plus 4, that's 6. 6 from 6, that is 0. So the formal charge here is 0. For nitrogen, the number of valence electrons in the free atom is actually 5. So we subtract from that the total number of non-bonding electrons plus half bonding. So the non-bonding electrons is 2. There are 6 bonding electrons. You divide that by 2, you get 3. 3 plus 2, that's 5. 5 from 5, that is 0. So the formal charge of nitrogen in this case is 0. If you look at that oxygen, the number of valence electrons in the free atom as usual is 6 because oxygen is located in group 6A. The number of non-bonding electrons is 6. Half of the bonding is 1, so 6 non-bonding electrons plus half of these 2, that is 1. So the total of valence electrons in the structure is 7. You subtract 7 from the number of valence electrons in the free atom, and that's 6, so we get -1. So -1 is the formal charge for oxygen in this Lewis structure. If you add these numbers up, so the sum 0 plus 0 plus -1, we should get -1, and we do. That's because the charge is -1, so that's reasonable. So the sum therefore will be 0 plus 0 plus -1, and that is -1. So that's satisfactory. If you look at this Lewis structure, clearly this oxygen makes 1 bond, so clearly it is -1. Double check. 6 non-bonding electrons plus 1, half bonding, that's 7 from 6, that is from 6, yes, that's -1. For that nitrogen, the number of valence electrons in the free atom is 5. 2 non-bonding electrons, and you add 3 of those, half of bonding, that's 5 from 5, that is 0. So the number of valence the formal charge of nitrogen is 0 in that Lewis structure. Of this oxygen, it is 4 plus 2, 6 from 6, that is also 0. If you add these up, you will also get -1. So the sum will be -1 plus 0 plus 0, that is -1, and that's reasonable because the overall charge is -1. To conclude, now, the nitrite ion is another example of an ion that exhibits resonance where more than one possible Lewis structure are available, and all bonds are identical, not only in bond length but also in bond strength.